Hello and a very warm welcome to this latest tutorial about the B4. Today we're going to look at the networking aspect of the B4. So here you see a B4 as it is standard, comes out of the box, and you remember that if you press the enter button you run a program like this one. 5 plus 4 is 9, minus 2 is 7, and we see all the activity inside the machine. Now there's one component that we want to take a closer look here today, and this one here is the automatic programmer. When you turn it on its side, you see it's sandwiched. It has a shield here at the top, and that is plugged into an Arduino Uno at the bottom, which then is connected to a laptop or a power source. Now this automatic programmer, as we call it, can temporarily take control of the B4. It can intercept the data path and it can send out control signals to various components. We use it during the programming process. So when the USB cable is plugged into a laptop and you use the Arduino IDE to program the B4 directly, which is the alternative to using the variables. Now, the cool thing about the Arduino Shield is that we can interface with it from external. So what we want to do today is we want to hook up the B4 to a wireless network. So yes, we want to connect it to Wi-Fi and then program it through a web interface. So we will have a little web page, and you can see it now, where we will type in our assembly code and then push the button, and then that data will get sent wirelessly to an interface, and from there to the automatic programmer Shield, and from there to the Arduino underneath. Okay, so what we need to do make that happen, firstly we need something that gives us Wi-Fi access, and we use this here. This is a Wi-Fi Shield. And to make this one run, we need another Arduino Uno, and we will connect the Wi-Fi Shield to the Uno like this. Okay, so we have a second Arduino Uno, or compatible, and a Wi-Fi Shield on top. Now, we need to connect the two, and for this we need wires. What you will need for this project are 4 1-pin male on both sides wires, and they will go into these female header pins. Now, if you look very carefully here on this side, our Arduino Shield, our automatic programmer, does not have female headers, so we need to get some like these here. All you really need is 2 2-pin female header pins. Okay, this one here is an 8 and that's a 2. That's what I had lying around, and I will show you shortly where they go. So we need to do a little bit of soldering here. One will go here, and the other one will go there. Okay, that's what we need. Here we only need to use a few of the pins. I will show you later which ones, but it's good practice to solder all of them in, which gives us a bit of flexibility. Okay, so this one here and that one there. In order to get them in, we will do a little bit of soldering. So let me just unplug the B4 and push it to the side a little bit. Take the female header pins out. And now we disconnect all the wires. Now I know where they go. My recommendation is take perhaps a photo before you unplug everything. It's also described in the handbook, of course. But if you take a photo, then you've got everything ready when we assemble it, because all the wires will need to go back exactly where they were. So we're taking this out. We remove the Arduino Uno. Careful so that you don't bend the pins down here. This Arduino Uno goes to the side. Okay, so it's now all about soldering on the shield. Okay, what I have here is a fantastic little holder which allows me to do the soldering. You might have something else at your school or at home, whatever works for you, to put these pins in and then hold them in place temporarily. In my case, I do it like this. It's a brilliant way of doing it. And then I just turn this around carefully. And here are the pins that I need to solder. Okay, I hope you can see this well. I've got my soldering iron. Okay, so let's do the soldering. That's number 1, 2. Number 4 done. This is number 5, 6, 7. That's number 8. All right, that's reasonably straight. And let's solder in the other one, which is here. This one goes down here. So these are the 2 serial port pins to receive and send data via the serial interface. We could have used I2C, but the current design of the shield doesn't allow this because one of the I2C pins is already used for other purposes. Therefore, use the serial interface instead. Works just as well. Okay. Okay, so that was all the soldering that we needed to do. Okay, this can go away. And our Arduino goes back onto the shield. Okay. Okay, so what will happen is that we will connect the Arduino with the Wi-Fi shield to the Arduino with the automatic programmer shield with our 4 wires. And I just showed to you because later there will be other wires which might confuse you. But what we will do is here is 5 volt. So that's the power supply. So 5 volt, that's the 4th pin from the bottom, will go into the 4th pin from the bottom here. Okay, easy. Then we also need to connect ground, which is the 3rd pin. Okay, so that goes to the 3rd pin here. So don't mix them up, otherwise your Arduino might get damaged. Okay, be very careful. So 4th to the 4th and 3rd to the 3rd. So ground to ground and volt to volt, or VCC. That's 5 volt that is, so don't connect the 3.3 volt. Now, here is receive data, or called RX, as you see down here. Now, in a serial communication, we need to cross over the wires. So the sending on the one side is the receiving on the other side. So you notice that RX goes into this at the top, which is here TX, and the RX down here goes to the TX up the top. So you see how the wires cross over. That's why it's good advice to use different colored wires. Okay, so you can keep them apart, tell them apart. Here's our orange, here's our white wire, and you see how they cross over. Okay, but don't cross over the power supply. Okay, that might damage your Arduino. This needs to be crossed over for the communication part. All right, so this lot will go back into our box. Or if your Arduino is on the desk, that's fine as well. So we leave that plugged in. This Arduino shield, the Wi-Fi shield, put this back in here. Okay, so if you haven't seen that before, here comes the magic. This is our data path, which goes into the shield down here. Okay, and then that's the data to the data RAM up there. This goodie goes to the program RAM. Then we plug in power. Okay, this one here is reset program counter. Okay, reset program counter is the first one. That's A, and this one is the clock override, which is B. C is write data RAM. So this is the data RAM control wire. So this goes into C. D is write program RAM. So that goes next to it. All right. And then E is our latch reset. So that goes in here. Okay. And this one here goes from the program RAM into the shield. All right, voila, we have done it. So we've just extended to the hardware of our B4 with the Wi-Fi shield. Okay, now if we plug this thing in, we can do it. Nothing much will happen beyond what the B4 already did. Okay, so I plug this one in. So it will behave exactly as before, and the reason for that is that the software underneath the automatic programmer still doesn't know how to interface with the Wi-Fi shield. Okay, so if I now run the program 5 + 4 - 2, there's no Wi-Fi function happening yet. So what we need to do is we need to develop some software for this part and that part. By the way, we call this one here the master, and this one is called the slave. Master because this one will host the website, and when it receives data from us, it will send it down to the slave, which will then execute the commands from the master. So just to keep things short, this one is the master, this one is the slave, this one has the Wi-Fi, this one doesn't. Okay, so we unplug that. We'll come back to it in a moment, and let's do some software development. Okay, so here's our code. This one is the slave code. What it does, it opens the serial interface at a baud rate of 9600, and then it waits for serial data to occur. It then checks whether it contains the keywords step or upload. If it's upload, it then clears the buffer or cleans the buffer, and then performs the standard programming of the B4. So you will see later how that looks. That's very simple. So it really just reads serial data and then passes this on to the automatic programmer. This is the master. It does a few more things than the slave, including access to the Wi-Fi network with the Wi-Fi shield. You will need to enter the station ID and the password for your Wi-Fi, either at home or at school. The setup routine then initializes the Wi-Fi shield, connects to the Wi-Fi. That can take a few seconds, 10, 15 seconds, and then starts a server. This server will then present us with a very, very small, very basic web page. And then inside the loop, what happens is that the web page is presented. You see a little form code down here. That's HTML, so a little HTML form. And when that is submitted, it goes back into this loop here, and we extract the information. That's a string of assembler code that we will have received. We clean it, and then we print this on the serial port. If you remember, with our slave, this one here reads on the serial port. It reads a string. So that is where the information gets handed over from the Wi-Fi shield to the slave, or from the master to the slave. All right. Okay, so the next step is to upload the code to the B4 and the Wi-Fi shield. First, we upload the master. So we connect our USB cable to the USB port of the master. That powers up the B4, but you don't need to be concerned about that. Then we go and check in the Arduino IDE which port is selected, select the corresponding port. That would look differently on your computer most likely. And then once that's selected, we upload it. And then you get an error. And the error is because this is a serial interface and this here is a serial interface, and they interfere with each other. So in order to have a successful upload, you need to temporarily disconnect those two wires. Okay? And then try again. Fantastic. This done, we unplug our USB wire here and plug it into our automatic programmer. Again, the B4 powers up, but that doesn't need to concern us. Again, we check that the port is selected. Well done. These wires remain disconnected for now. Make sure that they don't touch anything. And we upload the slave. Okay, well done. Now we reconnect the wires and again ensure that they are crossed over as mentioned before. So that's fine. Good. Then we open the serial port monitor on the Arduino IDE that's here. And we do this for the serial slave. Okay, slave is ready. And now we reset the Wi-Fi shield. So the Wi-Fi shield is now reporting via the serial interface, and it's like master reports. These are all messages from the Wi-Fi shield. So it's now connecting to the Wi-Fi, and then it is telling us an IP address. Here's mine. Yours would look different depending on your Wi-Fi network. But you can copy and paste that address into a web browser, and then you get the web page. This is now coming straight from the Wi-Fi shield here. Okay. Now you can zoom in and out, make this a little bit larger or smaller, whatever you like. Now we need some assembly code that we can upload to the B4 in order to test it. Now where do we get that from? Now we go back in here in File, Examples, scroll down to B4, and then you see is assembly example 1. This is the standard example which comes with a B4, a very small program that does essentially 5 plus 4 minus 2. Copy the string and paste it into this field here and click Upload. Instructions have been sent to the Wi-Fi shield. The Wi-Fi shield has sent them to the slave, and the slave is now uploading the program. So in the first step, we load the 5. So we click on Step, and we have a 5 up here. So here's a hot tip, by the way. In case your latch doesn't behave as expected, it's not latching the correct number, then we found that by playing with the clock pins down here can solve the problem. So usually you would have the pin down here to the very left. We found the latch then played up a little bit for this particular configuration. We just moved it 2 pins to the right. If that doesn't work, go a bit further to the right. So you need to experiment a little bit. Okay, so we have loaded a 5. Now we want to add a 4, so we click on Step again. Et voila, we have our 9, which is in binary is 1001. The next step is to subtract 2. Click on Step again. So the 7 is already here, which is now waiting to be latched and then written back into the memory. Now, also a hot tip, give it time. Don't press the Step button too quickly or the web server might hang up. It's a very simple web server. It's nothing that we can use for production. It's really just for experimenting. So stepping through the program, we have the 7 now, which has been written back into our memory. And we can click again if we like, and the program is finished. So we conducted a little program. 5 plus 4 minus 2 is 7. Now, what we can also take a look at is the serial monitor. What we can do here is make this a little bit smaller and see what happens. So when we upload a program like this one, then the serial port monitor is getting quite active. Let me just clear it here. So okay, the output and we can see what's happening. So if I upload the program, then the client, the slave, will give us this output. Okay, and now by stepping through the program, we get the step commands down here. If I press it, perform a clock cycle, and let's do this again, performing another clock cycle. You see sometimes the server hangs up if we press too quickly. So in this case, you need to reset the Wi-Fi shield just by pressing this button. The serial port monitor will keep you posted on the rebooting progress of the Wi-Fi shield. Okay, so just to wrap up, so what we have done here is we have extended our B4 successfully with the Wi-Fi shield. We have a tiny little web server which we can use to upload assembly code to the B4 through a web page. So I think that's very cool. If you followed this along and do this yourself, all the best. If you've got any questions or if you get stuck, drop us a note. And with that, we conclude this little tutorial. Thank you.